Hello students, welcome to the next module of the chapter Surface Tension, and in this module we are going to learn about explanation of angle of contact. Now class, to start with the module, I would like you all to have a look at the diagram which is shown on the screen. Now class, if you carefully observe the glass plate which is just immersed into water, if you observe in the diagram, I see that the glass plate, wherever it is touching the surface of the liquid, that is, if you observe the encircled part, yes, I can see that there is a small bend formed in the liquid. This bend is called as meniscus, and in this module we are going to learn about why do we have meniscus getting formed inside the liquid. So now, to start with, I say that I consider a system which is made up of three different media, that is air, water and glass. Now consider a single molecule of liquid. So I say that let A be the meeting point of all the three mediums, that is glass, liquid and air. Now class, this molecule A is getting attracted by all the glass molecules which are there in its sphere of influence. So, and that influence force is called as adhesive force, and that is shown by a blue colored arrow, that is Fa bar. Now class, the same molecule is also getting attracted by all the molecules which are there in the liquid, and this liquid force is called as force of cohesion, or I can say that cohesive force, which is shown with the help of Fc bar. Now class, molecule A is acted upon by two forces, that is Fa bar and Fc bar simultaneously. So the resultant of these two forces will be given by a parallelogram law of vector addition. Now class, I complete a parallelogram and the diagonal of the parallelogram gives me the resultant. So I say that on molecule A, the resultant force is Fr bar, which is shown with the help of green colored arrow, as you can see in the diagram. Now class, we know that the surface of the liquid always tries to be perpendicular to the resultant, and in order to be the perpendicular to the resultant, I say that the liquid takes a concave shape, something as shown. Now class, if you look at the meniscus, that is, if you look at the bent portion of the liquid, I say that that bent portion of the liquid is perpendicular to Fr bar, and hence I always say that the surface of the liquid always tries to be perpendicular to the resultant. Now class, in this case, the liquid which was there I have considered was water, and I see a concave upward meniscus. Now, replacing water by mercury, I say that this time I have three different mediums, and that is glass, air and mercury. Again, I say that let A be the meeting point of all the 3 points. Again, Fa bar is the force of adhesion between the molecule and the glass molecules. Fc bar is the force of cohesion between the same molecule and the liquid molecule. Now class, if you observe in the diagram, I say that the length of the red colored arrow is more than the length of the blue colored arrow. That is, I say that Fc bar is more in magnitude than Fa bar. Again, molecule A is acted upon by two forces simultaneously, and the resultant of the two forces will be given by parallelogram law of vector addition. So I again complete a parallelogram, and this time the resultant would be along the diagonal. And this time if I observe the diagonal, that is the resultant of my two forces, that is Fa bar and Fc bar, is inside the liquid. And as I know that the shape of the liquid surface is always perpendicular to the resultant, this time the resultant would be in the convex downward shape. So I say that the liquid would be something as shown. Now if you look at the meniscus, I say that the meniscus is bent vertically downwards. That is, the meniscus is perpendicular to Fr bar. Now, considering the last case, that is, I have again three different mediums, that is solid, air and liquid. I say that again I have A as the common meeting point of those three medias, and this time let Fa bar be the force of adhesion between liquid molecule and glass molecule. Now class, when we talk about pure water, the force of adhesion is so much high that we actually neglect the force of cohesion between water molecules. And since we are neglecting Fc bar, this time the resultant also would be along the same Fa bar. Now class, I know that the shape of the liquid surface is always perpendicular to the resultant, and this time since Fr bar is completely horizontal, I see that the shape of the liquid will be something as shown. It is as good as flat. So I can say that in order to maintain the perpendicular shape with the resultant, the liquid shape bends a bit in the vertically direction, which is very much close to the glass surface as seen in the diagram. So class, in this module we learnt about total 3 shapes, that is convex, concave and the flat surface. I hope you have understood the module class. See you in the next module. Thank you.